And then this ship on the bottom here, Archerfish, the very next assignment I had after the Air Force Command and Staff School, we made a port visit in Carthage, Tunisia. We pulled into Bizerte and we took a bus ride, and that's when I really understood the amount of remains that were available and visible of ancient shipping. So the picture on the left is what the harbor looked like in the 3rd century BC. That's when Hannibal crossed to Spain, crossed the Alps, and invaded the Italian peninsula. The picture on the right is what it looks like today. So you can see the circular island that had the military harbor and the very silted up commercial harbor in the background. That got me reading about the Punic Wars. That got me reading about George Bass and the Uluburun ship, what Texas A&M was and what that program is. And that's what sent me to Texas A&M, and had to pay attention by reading the books that I could find until I got my kids out of college. And then I returned to school after my youngest graduated from college. It's a little bit of luck where you end up working, because it amounts to what excavations are happening the first year that you're there. The first excavation I went on was a Venetian ship that sank in 1583 off the coast of Croatia in the Adriatic. And I was very lucky to meet a Croatian archaeologist. I asked her if there were Roman ships that could be excavated. She said, "You raise the money and we can excavate a ship together." And that's what happened in 2015. First, let me give you a little bit of geographic and historical background. So over here to the left is the Shin, the back part of the Italian peninsula. And then when you go around the Adriatic, you have Slovenia, and then Croatia, and then Montenegro and Albania. At the time of the Roman Republic, so the 3rd century BC to about 0, this was an area of operations, but it wasn't an area of permanent domination. The Roman Republic would send an army to the Dalmatia, Croatia area. At the time, it was called Illyricum. And then about 0, the Emperor Augustus took over and divided Illyricum into 2 parts, and the lower part was Dalmatia. When you say Dalmatia, there's a different story about Dalmatia of Roman times and Dalmatia today. If you visited Croatia and you've cruised the coast of the Adriatic Sea, the eastern coast, you see 1,200 islands that are along the Croatian coast, and the tan area that you see there is Dalmatia today. It was quite an impressive area in Roman times. It had crossed the Dinaric Alps. It took up parts of Croatia, Bosnia, Herzegovina, all the way through Serbia and Albania. The ship we're going to talk about was found near Split. Split is the midpoint of this coastline, and Split in ancient times and Roman times didn't exist. There was nothing there. The first relics found are about 100 or 200 AD, after the Roman Empire came into place. So if we zoom in on Split here, you'll see this nice bay. It's called the Gulf of Castella. The sound of Castella sounds like castle, and that's a remnant of the Middle Ages, when there were about 35 to 40 castles that were all along this coast. The 7 cities that are along this coast all start with the name Castel. The furthest east is Castel Sucerats, and that's where the excavation was. And you can see a little bit of a blow up here. This is not one of your deeper excavations. We were only 75 meters from land. We were able to swim out and do the excavation and then swim land. Didn't even need a support boat. So here's a geographical picture, and you can see splits here. Salona was a little bit in this northern or the eastern bay here. You can see Salona is a walled city, and the ship excavation is 3 kilometers away from the amphitheater at Salona. What attracts you to a shipwreck site? You've got to find it somehow. This particular shipwreck site, first a wooden wall was reported in the water in 1995. Archaeologists were there in 2002, and they pulled this piece of ceramic out. It's called a dolium. It's 1,000 liters or 250 gallons. And you can see holes that are drilled in about the upper 2/3. It was actually repurposed. The inside of the dolium is coated with resin, so it carried wine or stored wine at one time. Then when it was repurposed, holes were punched in it, and it became some kind of fish tank or perhaps oyster storage tank. So it would be sit in the ocean right next to a Roman villa or place. You catch fish, you throw fish in it, you keep them alive, and then you can have dinner, keep fish alive for several days while you're waiting to serve them. So this dolium came out of the water in 2002. Divers continue to work, and the next thing they find are what's called amphora. That's a two-handled storage container. This particular category is Dressel 20. That means it's made in Spain. It carries very expensive olive oil. And about 20 Dressel 20 amphoras were pulled from this hole here. And you can see where the dolium that attracted attention came from. In 2006, a fellow was swimming alongside this wooden wall, and he said, you know, I think I see the outline of a ship that was parked right against the wooden wall. So the first thing that happens is you send people down. It took 5 years to put a team together, but a Croatian team went and just did a dig just to see, is there a ship there? They're diving in about 6 to 10 feet of water, and they uncovered about a third of the ship just to confirm that it actually existed. And this is a nice shot. It shows you that it's not a trivial thing. This was a ship that didn't just sink next to the pier, it was actually scuttled there. So the ship was filled with rocks, and that's one of the reasons that the wood is preserved so nicely, because the rocks and the silt kept oxygen away from the wood. 2,000 years old, and you can still see the grain. It's in very nice condition, and made it clear that there was enough here to have a full-scale investigation. So I'm going to try a little bit of a video just to show you a little bit of the area. So you can see the aluminum grid here, which we laid out over the ship. And this is the coastline of the northern part of the Gulf of Castella. And we're flying a drone over the coastline. And you can see the town of Castella. This is the first of the 7 towns. And the drone will just fly up over the town and then turn around and fly back to the excavation site. This was taken in April of 2015, so the weather was very nice. We had 23 days of diving scheduled, and we only lost 1 day to bad weather. So now flying back, this is the city of Split, and Diocletian's Palace is just over this rise. The amphitheater and Solana is here, and you can see this coastline. Unfortunately, a nice cement factory is prominently featured here, construction of Yugoslavia. But you can see this road is right over the top of an ancient Roman road, which drove along the coast of the northern part of the Gulf. And now we're flying up alongside the excavation, and we actually rented one entire house so we could have the team there. You can see all of our wetsuits drying, all of the equipment. Air compressors were set up, had a few rooms in this house. And so the ship's here, and we had water dredges that ran on gasoline on this pier, and we ran here. So after the heavy rocks were moved by brute force, we were able to use dredges to clean the wood and make it clear enough to be able to label it and then take photogrammetry. And I'll talk about photogrammetry in a minute. The team varied. It was about 15, 18 people, but some people would come, other people would go, depending on who was available. We had, I think, 5 Americans, Slovenian, Italian, Croatians, 1 Montenegrin. A very international crowd was associated with the excavation. Buoys on the edges of the grid, and you can see people are basically just under the surface of the water as they're working on the ship excavation. The grid was an important thing to have. This was one where you could take a lot of lead weight, weigh people down very heavily so they would be plunked right on top of that aluminum grid. And then they could pull heavy pieces of rock out, or they could hold these pretty heavy dredges and be able to get work done, or they could do very delicate work by labeling each one of the individual wood components or looking for ceramics or glass artifacts. That's one of the unfortunate things about excavating a ship that was scuttled 2,000 years ago. When the Romans scuttled the ship, everything of value was pulled off. So there was no mast, no mast step, no sails, no sailing equipment. We found one oil lamp, one coin, and about 200 broken pieces of ceramic as we excavated the ship. The excavation went through with labeling. Some of the wood was in better shape than others. As you got further up the side of the ship, strakes away from the keel, you can see what the poor condition was here. And so we did the best we could to keep it from floating away. These are kebab sticks that we use to stick into the wood to try to hold it in place until we could get the photographs taken. The way this worked is we pulled the big rocks out, we pulled the little rocks out, we used this dredge to get the silt off, and then we labeled, and then we took pictures. It took about 4,000 pictures to make this picture. There's a computer program, it was called PhotoScan, now it's called Metashape, but it combines pictures and makes a 3D scalable and measurable model. We did this twice on the ship. First, we did it, these long pieces of wood are called stringers. Maybe you call them ceiling planking. I'm not sure what they're called on Gundalow, but they are nailed across the tops of frames. And then we pulled those stringers off so that we could study the actual way the frames were connected and how that went and was put together on the ship. Once you make the photogrammetry model, you're able to spin it around, take a look at it, make measure. Whoops, let me go back. Make measurements, spin it around. You can pause, you can go through, and this is one of the things that I want. Okay, I'll figure this out in a second. There we go. All right, try again. All right, well, I'm gonna have to do it quicker. What I want to show you is the ship helped me out. There's a curvature of the ship. The port side, we're looking from west to east. It was bow to the east. The port side of the ship, which was right against this wooden seawall, the curvature of the ship was preserved. So we were able to understand exactly what the curve was. The starboard side broke twice. You can see it's broken here. You can see another break here. That meant a lot more of the ship was preserved. And so we were able to use that to our advantage, or I was able to use that to my advantage in reconstruction by using this additional length that was on the starboard side of the ship and extending what was preserved in the curvature on the port side of the ship. And I'll talk about that in the model reconstruction. We left this one stringer in place because it had some interesting wood ledges that were on it. It was different than all the other stringers, so we went ahead and left it there. The wooden wall still remains to be examined, and there are lots of wooden posts. You can see 2 posts, here's 2 posts. It's a very complex site and deserves a lot more work. After you make the plan, you've got to figure out how is the ship built. And so it has keel, a stem, and a stern piece. And we took about 400 wood samples during our excavation and sent those off to have them identified. And it's complicated. It wasn't let's use oak for all of the frames, let's use cypress for all of the planks. It's a very random construction. This ship was built differently than ships you're used to seeing built, which are skeleton first. Typically you put the frames up, you nail planks, and then you make that hull watertight. Roman ships that were built with mortise and tenon, the hull was built first, and then frames were placed inside the ship and pegged to the hull. So these are the strakes, the keel, stem, and stern to the middle. There are 11 different rows of boards or strakes on each side. And then there are a piece called a whale, which is smaller and thicker, something that adds strength, as sort of a band around the ship. Only 2 of the whales survived on the port side, but we had a small piece of a whale that survived on the starboard side of the ship. And then we were able to use that information and compare to other ships. I had to split the frame construction into 2 pieces just to get it all on. 69 frames, 214 pieces of frame were laid out. Once you get the information, you get everything labeled, you've got to start putting it into a computer program and understand. So first of all, where did the stringers go? What were they touching? I think if you look with symmetry, you realize the stringer that's closest to the keel on the port side must have been removed in ancient times before the ship was filled with rocks. But we have all these other pieces. Everything is nailed to the tops of the frames, except for this one stringer, S46, which is probably a piece that was pulled up here, flopped on top here, and then it was filled with rocks. Sample-wise, 3 main pieces of wood. The very light green is Aleppo pine. That's what the majority of the boards were made of. The darker green is black pine, and you'll see this a lighter color here is made of cypress, and then 1 piece of stone pine, 1 piece of Scots pine. You can also see these 2 what we call graving pieces. In other words, the ship was built, it ran aground or hit something, had to be dragged up on the beach, and they replaced these small sections with new pieces of board, and you can actually see the repair tenons that pegged that part of the repair into place to keep it watertight over its life. So cypress, Aleppo pine, black pine for the stringers. The concentration matches the planking choices very closely. So they looks like they use the same type of timber for the planking that they did for the stringers, and they use the same lumber yard. Framing is extremely different. When you inspect something in the Navy, you look on the port side, you look on the starboard side, which one's different? If there's a difference, there's a deficiency there. That's not the way the Romans thought. These 2 pieces of frame, frame 4011 and frame 4012, this is the same kind of wood. You can just see this piece is twice as thick here, different sizes, different shapes, different cuts, a lot of complicated lining up. Each one of these white tacks is a wooden peg that was, a hole had to be drilled through the frame, and it had to be drilled through the hull of the ship, and then the peg was hammered through from the outside in to hold that frame in place to give strength to the ship. One of the things that's interesting about the ship is the framing pattern itself. So if you look at the bow and the stern, the density of framing is significantly different than the framing density in the center part of the ship. And it basically doubles when you look at the framing. Over 50% of the center midships part is actually covered by frames rather than unexposed hull. What that tells you is the ship is carrying something heavy. It had density, dense cargo. That gave me something to go research as far as what could that be? What are some historical comparisons? Can we find wrecks that have this type of framing pattern that's sunk in deep water? That way I can look at what the cargo is and try to make conclusions about what this ship was carrying in and out of the port of Salona. Framing pattern, 11 different kinds of wood used in framing. Again, Aleppo pine is the most common, but it had Turkey oak, white oak, black pine, cypress. There's 1 piece of olive we found, a lot of sycamore, elm. It's a hodgepodge of work. One of the theories of some archaeologists is the more different kinds of wood and the less homogeneous wood is, the less value the ship was constructed with. These folks went up, found whatever the next piece of wood that would fit, didn't matter what kind it was, took it back down and put the ship together. Of those 69 frames, we call them floors because they actually cross the keel in 1 piece instead of a half frame, which would be 1 to port and 1 to starboard. Of the 69 frames, 11 of them had notches cut in them for some reason. Different measurements for different notches. 2 of the frames, these are both chestnut, had double notches that were cut in them. And you can draw a few conclusions about that. The first conclusion to point out is these 2 frames aft, one has a notch facing aft, this is a notch facing forward. The 3 frames between, instead of having a limber hole, which is a hole that allows water to slosh back and forth, they had a notch cut in their frames. So the best theory here is there was a chain pump that was installed here that was able to empty the bilge of water while the ship was operating. There's several ships that have been excavated that had their mast step. This double notching pattern is very common to support the heel of the mast, to keep the mast step from shifting So most likely the mast itself, the end of it was under this spot here. That would have looked something like this. Here's the 3 frames that had a notch to show where the chain pump operated. Here's where the heel of the mast would have been. This is about 4.5 meters of length of a 12-meter ship. So right at about 1/3 of the length of the ship could have been the mast step. That's long, but it's not as long as the longest ones. There are some ships that are over half of the ship's mast step is the length. Unfortunately, the mast step was removed. That'll have to be conjecture, but there's still some information to be elicited from that. One of the tough parts of excavation is the expense of actually removing the wood. If you pull wood up, it is now on that excavation to preserve the wood. There's several ways to do it. You can soak it in polyethylene glycol. That displaces the water, gives the wood a waxy feel, and holds its shape. Another way to preserve ancient wood is to freeze dry it. You take the wood, disassemble it, label, move it into a freezer, let that freeze dryer work for about 6 weeks. It pulls the moisture out. When you get the moisture out, the shape is still there, and then you can reassemble the ship. Both of those methods are very expensive. So this ship was excavated by uncovering. We took pictures, we took samples, and then we covered the ship back up to seal it. And we're looking now for some funding for another return to the ship in the future. What I want to do now is just walk through for a minute and talk about some of the computer reconstruction. This is one of the things that's tough about being a not young archaeologist, is figuring out how to run the computer software and the simulations. Archaeology is not a rich science. We need to piggyback on civil engineering, petroleum engineering, deep water exploration, use that equipment and their techniques to continue advancing archaeology. This program I'm in now is one called Rhinoceros. It's a 3D modeling program. So I took that 3D model from Metashape PhotoScan, imported it into Rhinoceros, and then I drew lines and cut a bunch of section lines across the model. And I found each intersection of every one of those strakes, each one of the planks that built the model together, so that I could understand how those strakes were put together, where the joints were, and how I could model. I took each one of those cross sections, and then you could draw what it looked like. So here's a specific cross section. You've got the keel. Here's the curvature of the ship on the port side. So we're looking from forward to aft. So port is on the right. The keel, the curvature of the ship to port. And you can see in this particular spot, there was a break in the hull, and it made it to the first whale for the starboard side. You take that, lay it along where the keel, the entire keel, and the computer program will let you basically copy and paste. So copy the starboard side, copied it in red, pasted it on port, took that port and bent the hull of the ship back up into place where it would have been. Used that to come up with the inside points for each one of the individual strakes along the port side. And you can build a rough outline for what the ship would have looked like. So you put together from bow to stern, first whale, second whale, and we had a very small portion of the third whale that was preserved. And you come up with these lines that represent cross sections of the ship along the keel. You can take that back into the Rhinoceros program, and this is where I got a lot of help, I admit it, and try to isolate. What I was basically trying to do was a 3-dimensional least squares fit. What's the best way to take these lines and line them up such that it creates the same smooth hull that the shipbuilder built 2,000 years ago? So take the points, make hull sections. It builds a hull surface, and then you iteratively go through to build a hull. That hull can then be suspended in a block of water, and I can change the depth of the ocean on that block of water and say, all right, if its draft is 1 meter, what does that mean the ship displaces? If its draft is 1.2 meters, what does the ship displace? And then, because there's now a model that exists with curves, you can extract what's called the ship's lines, which is a picture shipbuilders will use to understand what's the shape of the ship. My confidence level for the bottom of the ship, extremely high. The turn of the bilge, very good. What the ship looked like at its cap rail, no idea. Nothing survived. So rather than try to draw something with beautiful artistry, I left a curve at the top and stopped there. But you can see the frames from 11 to 79. There was one canted frame. I would very much have liked to have seen more frames that survived, but it didn't. And then for each one of those frames, 3 whales, and drew in across the 11 surviving strakes what the different 214 pieces of frame component were, just to document where we found it. This is the extracted set of ship's curves, and you can see how flat-bottomed it is. Very flat, very steep sides that are associated with that. And this dark line here is a capture of exactly how much remains survived for the ship. What is it? So you say, okay, Dave, that's great. You spent 3 years trying to understand the ship. What was it? What did it do? Well, like, as you know, with the Gundalow, a ship does whatever you need it to do. A ship hauls whatever is available to haul. What are the things that are moving in the Adriatic in the 1st century AD, which is the radiocarbon date, somewhere between 33 and 120 AD for when the ship was built. So cabotage, moving cargo up and down. These are the same. These are amphoras of a different kind. These are Lambolia 2, which is the most common Adriatic design. Another theory out there is the ship delivered roof tiles from Italy to Dalmatia and returned with raw materials from Dalmatia to Italy. That tree could be trees, could be tin, could be marble, but some amount of cargo was taken back, raw materials, and the finished goods were roof tiles. And you can see this is a shipwreck that was found with roof tiles that were stacked, and the weight of the tiles preserved the hull of the ship. Another ship, this one was found between Sardinia and Corsica. Again, you see the very close spacing of frames, and longitudinally across those frames, this ship was carrying lead ore. So these are very heavy lead ore. Again, makes sense for some ship that had an extremely concentrated amount of frames. Lead ore was in the center of the ship, and these circular discs forward and aft were copper ingots. I believe it was 8 tons of lead and over a ton of copper came off of this shipwreck that was in the Tyrrhenian Sea. Probably the most likely is carrying marble, quarried granite rocks. The island of Brach is about 20-25 miles away from Salona. Tremendous evidence of sarcophagi from excavations in Salona. You would cut a block, roughly shape it on the island. Nobody lived on the island. There were no families there. It was a Roman mine, and ships moved those quarries back and forth. This particular picture is a ship called Sudavon that had several large blocks that preserved the hull of the ship. And again, you see the densely spaced framing. And the last one is the one that's most interesting to me. I know you're not supposed to hope, but wouldn't it be nice if the type of ship that was recovered and found because of a dolium turned out to be a dolia carrier? And so a dolia carrier, those same big dolia that were there carrying wine, think of them as the super tanker of the 1st century AD. Huge dolia put amidships with amphoras forward and aft. You could fill it with wine, you could fill with grain, you could carry olive oil perhaps, and then move those cargoes back and forth. There are 2 dolia ships that have been found in the Adriatic and another 13 that have been found in the Western Mediterranean. That will be difficult. I took a look at the dolia that originally found. It doesn't look like it has any wear marks from being on a ship. Doesn't look like it has any rubs on the bottom from being cargo, but another possibility that's out there. So where are we so far with the ship after 22 days of uncovering and taking pictures? Heavily constructed, well-used first century, perhaps early second century. It's a 25-ton displacement with 1 meter of draft. It's about 13.5 meters long. My chair told me when I excavated, you're going to want to go back. No matter what you do, you're not going to get all the information you want. He's right. There are several places I would have loved to have disassembled, taken some additional samples. I'd like to have looked at cross sections of the keel. That'll have to wait for the next, for the return to Tristanique. And the last thing I'll say is historical comparison. You need to understand the historical comparison, but it's not enough. There are too many options. There are too many choices. A ship can carry anything, and it's very difficult to say what a specific ship was built for and what it was used for just by looking at the hull after everything of value has been removed from the ship. And so with that, I'll open it up to questions if anybody has it. Thanks.
All right, Dave, go ahead and you can stop sharing your screen.
Oh, okay, good idea.
There we go.
How's that?
Good. So we had a couple of questions that were sent through the chat room while you were talking. So let me get to those. The first one has to do with the wood for the construction of the ship. And the person, Chris Gillard, says, it sounds like the wood for construction was from the Levant. No, L-E-V-A-N-T, Levant.
Yes. The Levant is the Syria, Lebanon, Israel, the far eastern coast of the Mediterranean. And unfortunately, the climate of the Mediterranean is such that most of the trees grow in most of the places. And I worked with a Spanish woman who is trying to do her dissertation on what trees grew where 2,000 years ago. Aleppo pine, very common everywhere. Turkey oak, very common everywhere. One of the very interesting things, one frame is made of Turkish pine. Turkish pine only grows in Turkey, very far to the east in the Mediterranean. It would be great to say that proves the ship was built in Turkey or somewhere in the Aegean, but could that one frame have been a replacement? Could it have been imported somewhere else? It's hard to hang your hat on one piece of wood. I would love to go out and draw a bunch of pictures of this tree has this distribution, this tree has this distribution in 100 AD, and be able to point on a chart and say, yep, it had to be built here. The level of knowledge of where trees grew 2,000 years ago isn't quite there yet. The other piece that would be interesting is to be able to cut some of those planks longitudinally and do some tree ring studies, dendrochronology, where you can try to look and say, look, there was a drought in this year and this year and this year, and it lines up exactly. That tells us that this piece of wood must have come from the Italian peninsula, or it came from the Alps around the area of Salona. We don't have that information yet, and there isn't a catalog of dendrochronology for the Adriatic area yet. But there's people that are working on that, and each one of these excavations lets you chip away a little bit at what do you know and what was happening in that time.
Okay, next question from Kathleen Luz. What organizations / entities / people financed the project, and what was the pitch to get the resources needed?
Boy, am I embarrassed that I didn't tell you all that the very first sentence as I started my brief. I'm wearing a shirt, let's see, I don't know if you can see it, it says Institute of Nautical Archaeology. Texas A&M and the Institute of Nautical Archaeology have been partners since 1976. It's a nonprofit that most of the professors who do nautical archaeology at Texas A&M are a part of. I was very lucky to win a grant from that organization. I also had some support from several labs at Texas A&M, the Center for Marine Conservation. I also had some support from the University of Zadar in Croatia. And archaeology doesn't happen without support of people like you. who make this work. Because of the work I've done with the Institute of Nautical Archaeology, I'm now a research assistant there, and it's a partnership that I hope to continue to work on. Ina made its name at the Bodrum Research Lab, which is Turkey. You may have heard of the Uluburun shipwreck about 1380 BC, an ingot wreck. Ina has several other wrecks that they've excavated in Ionian Greece or the coast of Turkey, and they're working on another wreck in Turkey, depending on whether life gets back to normal this summer, but it could be dated as early as 1700 BC. So the history of shipwrecks continues to get pushed back further and further through these excavations.
Okay, next question from Alan Gold. I'm curious how the ship remained unexplored for so long. Was there a weather event or some other event that exposed it, or was it known but ignored until your effort?
I'm going to have to go with column B. It's interesting in Croatia. You can't put a shovel in the ground, turn a rock, dig a foundation. There are artifacts from multiple eras just about everywhere that you look. This particular house where we were working, the owner of the house showed me a picture when they repaved the road in front of his house. There were Roman graves underneath the asphalt. So just the entire coastline, it was Roman, it was Venetian, it was Ottoman. A friend of mine there, when it rains, walks his dog and looks for coins. He finds ancient coins just because it rains. This specific one, the residents of that part knew that the wooden wall was there, just didn't make a lot of interest to them about reporting it to archaeologists until the late 90s. I think that's interesting because it's right after the Civil War that happened as Yugoslavia dissolved. People aren't really interested in archaeology when they're at war. But things calm down, cultural interest grows, the wall gets reported, the dolium gets found, and you move forward from that. And I have to believe there are many, many other sites just like that in Croatia and all along the Adriatic coast. France, they've explored Jacques Cousteau. They've been diving off the coast of France since the 50s. I think they've pretty much found wrecks that are in diveable water. Croatia, it still has a lot of potential, and there's a lot of work to be done.
All right, next question from Roger Layton. Compared with Norwegian longboats, which had plank first, frame second construction, who came first?
The Norwegian longboats are what you call clinker built. So the edges of the planks don't abut, they overlap. And so it's a different design methodology. It's hard to say. Everybody wants to draw a flow chart and say this construction style begat this construction style and this came from here. The three main Mediterranean styles, the Egyptians in 3000 BC, Khufu's barge, they had what's called lash construction. They would leave an arm of wood and lash the ship together. The Phoenicians, mortise and tenon construction. You cut a notch in each side of the board, you slide a tenon, and then you peg it. And the Greeks sewed their boats together. Lots of small holes, and would actually use fabric and sew the ship together. So did the Norwegians come up with their own? Did somebody sail up there? It's easy to look at a longboat and say, that's clinker built, that's a design frame. The people in the Mediterranean want to say, our mortise and tenon was adapted by Norwegians and Germans as they built clinkers in the 1300s and 1400s. The Norwegians want to be independent. We came up with this idea. We've been seamen for thousands of years. This is our design. It's hard to connect it. Boat builders built like their dad. What did my dad do? That's how I'm going to build it. That's the safe way. We're not as fast to inject new technology. So it's very difficult to track. Here's this style that then appears here. There are a few exceptions to that. You can see the Romans stealing ideas from the Carthaginians. Wow, they make better ships than we do. We're just going to copy them. The Romans were great copiers. But the Norwegian one, the jury is still out. It depends on who you ask as to what answer you're going to get.
Kind of like the Soviets with a little extra help, huh? Okay, next question. Say a little bit about the challenges and rewards of this work done underwater.
It's rewarding in several ways. First, when you excavate a grave, and several times I've been at excavations where you dive for a day and then you dig on land for a day. If you excavate a grave, you're getting what that individual or that individual's family wants you to believe about them. This is their perception. This is our art. This is exactly what we think. If you excavate a ship, I don't want to go down it's like Pompeii underwater, because ships are not Pompeii. But if you excavate a ship and you find 4 cups and 4 plates and a kitchen, there were 4 crewmen on that ship that were working there. And you're able to understand, how was his day? What was his life like? What was the cargo like? What I'm interested in with excavating this specific ship, how did that technology transfer? Why are the Romans, who just visited the Dalmatia area of Illyricum and then it became Dalmatia, how did their technology show up in 50 or 100 AD? Why isn't it the sewn technology of the Liburnians, which they were still showing ships at exactly that same time, 100 kilometers up the coast? So there's a technology transfer that's interesting, and there's a trade piece that's interesting. What's important to people is what they trade for. What am I buying? What am I selling? How am I earning money? And that part is preserved better in a shipwreck underwater than it is by trying to, there's some impressive work that's gone on. Let's go count pottery sherds and we can understand how much olive oil came here in 50 years. I think if you also go down to a ship and you look, you get a better snapshot. You need lots of snapshots to make a big picture. One snapshot that's interesting, we've excavated hundreds of wrecks in the Mediterranean. You don't find money. So there was a lot of trade that went on with some kind of paper records or knowledgeable records. There's not huge stacks of money. Pirates didn't pull over ships in the 1st and 2nd century AD to get money. They pulled it over to get crew or to get material or to steal the entire cargo. But the ships were not buying and selling with a wallet that belonged to the captain, for example. As far as diving, there are lots of young archaeologists out there, Croatian archaeologists that I've worked with, probably 20 or 30 by now. They love the history that their country is now exploring. They love the technology. And the days of, I love George Bass. He's still alive. He's 85 now. He lives in College Station. He's the Americans call him the father of nautical archaeology. But countries are not interested in Americans coming to their country and telling them their cultural history. Countries are interested in help. Bring us your technology, show us this, or come work with us, or just bring money and shut up. There's different ways to define what countries are looking for, but they're not looking for Americans to parachute in and tell them what their history is. So I think that's what the future is going to be, are partnerships, international excavations that continue to advance our understanding of what nautical archaeology is and where it can take us.
All right, that question was from Nan. I forgot to tell you who it was coming from. This next question is from James Jensen. It says, how many ships like this were in service at the time 2,000 years ago, and were the seas crowded?
Well, it's hard to say. How many do we find? I've seen estimates that say there are 30,000 ships on the bottom in the Mediterranean. If 1% of the ships sink, that's a lot of ancient ships that are down there. We really only scratch the surface with scuba. I'm a recreational scuba fellow. 100, 120 feet is about as far as I want to go. You can use mixed gas to get to 300 or 400 feet. I'm excited to be partnered with another nonprofit called RPM Nautical, that has an ROV that can go down to 3,000 feet. It's nice to be able to touch, but when you can't touch, it's nice to be able to go down and take pictures and understand what you're looking at. As far as the seas crowded, I don't know if there were collisions or running aground. There had to be some, ports are always crowded. But what is a port? We know of a few imperial unique places like Putzwali or Ostia or Ravenna. But by the same token, where this ship was excavated could have been a port where you drag a ship up on land when you need to do work, you unload it or load it, and then you push it back in and it goes back to sea. So some of the concepts that we have don't exactly fit the way the Romans and some of our ancient mariners operated their ships.
All right, next question from Joan Beskinis. Does Croatia have any interest in this restoration?
Everybody is interested, nobody has money. And so that's the fundamental thing that happens with all nautical archaeology. How do you pick those few unique, special ships that deserve to be conserved, put on display, build a museum, and you have to make an argument, because if your ship gets excavated and conserved, that's another ship that is never going to be pulled up. So certainly Croatia is interested in museums. Politicians see it differently. Politicians see it both as, let's preserve our culture, but let's also create jobs. Let's also create a museum. Let's enhance how much tourism that we get by building an attraction. I've been working with a group in Albania that very much wants to excavate a ship, any ship. They really don't care because they want a museum. And that's probably not the best way to make a decision for how to spend that kind of money, $250,000 more to be able to pull a ship up, do the job you need to do, and put it on display.
All right, next question from Gianna O'Brien. Did they use different kinds of woods in different places on purpose?
Yes, the stereotypical, no ship is perfectly designed, but you would typically see the entire planking to be made of softwoods, Aleppo pine, black pine, some kind of cypress, and the frames would often be hardwood, but there are exceptions. There have been some ships found where the planks were actually made of oak. So there was an extremely amount of expense put in to shape that hardwood into planking and be able to use it. From the Tristanic ship perspective, you can see a lot of use of scrap wood as well. Because Aleppo pine was a commonly used wood, you see a lot of the pegs that came out of the frames were made of Aleppo pine as well. The only piece of beech is the keel. No other beech we found on the ship. Did that piece come from somewhere else? Was it imported? Why was there no other beech available, but they used the biggest timber board beech? Hard to say. So another one where it's difficult to talk about pegs when you haven't disassembled the ship and taken a look at every piece. And so there's more work to be done to really get statistical data on the ship that I excavated.
Okay, we've got time for just a couple more questions. Next one comes from Al R. It says, how will the information derived from this dive be used?
So you take this, and first I presented the results at an international shipbuilding conference that happened last year. And then you use it to continue to build the library of ships. So there are folks out there who say in the 2nd century BC, we have 4 examples of Roman ship in the Adriatic, 2 examples of Liburnian ships, and you continue to build this library to try to understand what was happening and what changed over time. There's some works where there are people who will graph how many shipwrecks have we found in each century. And you see that Imperial Rome, the 1st century, 2nd century AD, tremendous amount of traffic in 1st century BC, 2nd century BC, and as the empire faded, the amount of ships on the water apparently faded as well, because we don't find those wrecks anymore. So however you imagine it is the information you can pull out. Is it ship density? Is it cargo density? One of the pieces that a pretty smart fellow pulled out is look at where the stone wrecks are and how much stone moved. And he was able to show that when Rome decayed away and Constantinople became the major part of the Roman Empire, the stone ships were sailing into Constantinople instead of to Rome. And that was why the route of stone changed. So he could say, look, a 3rd century AD ship is not going to be found in the Tyrrhenian Sea. It'll be found in the Ionian or the Aegean Sea. So you can understand and measure global from that perspective change based on what you see on the bottom of the ocean.
Okay, next to last question from Luke Lane. Sorry if I missed this. Are you able to estimate the cargo carrying capacity of the ship in either gross tons or dead weight tons?
Yes, 20. It of course depends on draft. I think it was about if you look at iconography of Roman ships, typically the lowest whale is right at or just above the waterline. So when I take that lowest whale and I adjust the draft of the ship, it says the ship displaced 25 tons. Hard to say how much of that 25 tons is ship's equipment and how much of that 25 tons is cargo, because I don't know how much of the ship got removed. But gross weight, the entire weight of the ship, I think 25 tons is a good estimate for that ship. And for a ship 13.5 meters long, looks like it tracks with the reconstructions of 2nd century, 3rd century AD ships as well.
All right, last question. Another one from Roger Layton. Was this a coastal cruiser like the Gundalow or a Voyager?
Without a mast and rudder, it's hard to say, but when you look at a ship of that size, it had to be able to get underway and at least make it across the Adriatic, go to Brach, go to Ravenna, go to the Italian peninsula, and the Adriatic is ocean. And so it certainly could have cruised up and down and done cabotage and delivered cargo, but the nice shallow draft would have taken it wherever it needed to go in the Adriatic. And we found ships that were loaded smaller than the ship at Tristanique that in the Adriatic that were loaded with amphoras that were made in Africa. So small ships certainly made large, dramatic voyages in ancient times.
All right, well, I think that's going to wrap it up. I want to thank Dave for spending the time with us this evening and filling us in on the construction and the use of these kinds of ships. I think it's fascinating, the stuff that you were presenting, especially when it had to do with the way the ship was constructed. For those of you that joined us late, this presentation is being recorded and we'll have it out on our YouTube channel within the next couple of days. Stay tuned. Next Thursday, we're going to have another one of these Gundalow gatherings. This one is going to be on the video called Row Hard, No Excuses. And you're going to have an opportunity to hear about 2 gentlemen who actually rowed across the Atlantic Ocean several years ago. So we'll have that. Hope everyone's staying well. And if you have any questions or concerns, or you just want to give us some feedback, please let us know via email or give us a call. All right, everyone, we'll see you hopefully next week. And thanks for coming out and spending some time with us. Take care.